Afternoon, everybody. Welcome to our third webinar of the series Meet the GSEU. Today, we are very happy to discuss with you our work that we are doing on enhancing cost of vulnerability assessment and adaptation of strategies. Before we start, I'd like to guide you through a couple of quick guidelines. So first of all, good for you to know that we are recording the webinar. So we are very happy if you interact with us via the Q&A or the chat or asking question personally. But if you prefer to write in the chat and the Q&A, I will read the questions out loud for our panelists later. For these reasons, because we have already 27 people attending, so your microphone are muted by default. And if you want to interact with the panelists, and again, please do so. Please raise your hand or write the question in the Q&A or in the chat section. So the agenda is quite simple. I will give you a quick introduction about the Geological Service for Europe project. Then our group leader of the Coast and Sea, and I'm going to give you an introduction about the work that we are doing. Then we are going to move on a more technical presentation about cost of vulnerability and climate change. And finally, we conclude with an extensive question and answer sessions. So the three speakers that you will meet today are Eleftheria Poyiadji. She's the director of the Natural and Technological Hazard Management Department of the Greek Geological Survey. Then the second speaker will be Aurelie Maspataud. She's the head of Coastal and Risk Project at BRGM, the French Geological Surveys, together with her colleague Rémi Thiéblemont, also a research engineer at BRGM. Before we start with the presentation, I'd just like to remind you that we are very active on our communication channel, both social media, website, and YouTube. So if you're interested in seeing what we are doing, you can find a lot of information and material on the different platforms. And you're always encouraged to get in touch with us if you want to know more. Great. I'd like to share with you now a few thoughts about the GSEU. So bringing the subsurface into the light is our motto. Why we wanted to start talking about the thinking about the Geological Service for Europe. So these are some of the headlines that I found on European news in the past years. And you see that is a very broad range of problem of discussion that are related to energy transition and decarbonization, for example. So we are talking about, of course, critical materials, energy storage. We're talking about what are the risks that keeps the bankability down of large-scale exploitation of geothermal energy. We're talking about climate change or like the lack of water resources. And what you also see that is not like a national problem. So we are talking about always Europe, talking about the World Bank. These news can be found in Greece, France, Spain, I mean, all over the world, and especially all over Europe. So for this, we could identify two main needs. So the first thing is that there's a critical need of high quality surface data, subsurface data, and then that problems are not only national, but are pan-European. So then pan-European problems require a pan-European effort and solutions. For the first problem, we started more than a decade ago. Our online platform is called GDI, the European Geological Data Infrastructure. And we are working really hard, both from the inside, so to improve the architecture of the platform and to always add new products that are useful for a broad range of users. And related to the pan-European problems, well, we have a gigantic consortia, so it's 48 countries from 35 countries, because we need to zoom out and go beyond the national borders. So our objective is actually to create a sustainable independent organization that will work as a network of European Geological Survey organization. And the GSEU, so the project will structurally address specific challenges in the sustainable management of the subsurface at EU level. This infographic a bit visualize our mission. So we started from interoperable geological data and via 3D geological framework. So we cover all different topics that we'll see in a moment. And at the end, what we want to do is want to support policymaker with high quality data and excellent geoscientific expertise. So both data and knowledge of the subsurface. We want to do that because it's obvious that all the Green Deal policy and Earth system are interconnecting. And for example, only focusing for a moment for the topic of this webinar. So the Renewable Energy Directive and the marine strategies are strongly connected to our group that is working on coastal vulnerability and wind farm siting. So we cover a broad range of topics that goes from raw material, geoenergy resources, so geothermal, hydrogen storage, and CO2 geological storage, groundwater resources, both quality and quantity, geological thermal setup, so where we are talking about metadata, standard, harmonization guideline, etc., and of course coastal vulnerability, that is the topic of our meeting today. And all the work that we are doing there is going to end up into our online platform. Everything we do is open source and available. So already both on the platform and on our GSEU website, there is a long list of products that and maps and report that you can already freely download, read. This is already it for me. Again, we are very happy to see a nice online audience, and I'd like to give the word to Eleftheria, in which she will give a first introduction about the work that we carry on coastal vulnerability. Eleftheria, please share your screen.
Hello, everybody. I believe you can see my screen now. I will talk to you about coast and sea, and especially for coastal vulnerability. So our objective is to deliver products and services, not only geological data, for all interested parties. These could be the governments, the policymakers, the research people. And these products and services will enable them to make informed decisions regarding the sustainable development, management, and protection of coastal environment and the seabed. We are dealing on two separate matters. It's the coastal vulnerability on one hand and the offshore wind farm siting, for which you can join us again on next week on the 24th of September. Let's move to our theme now, the coastal vulnerability. So why now? Because coastal areas are sensitive zones that require careful management, and we have an increased pressure due to human activity. We have urbanization, we have constructions of dams or construction of artificial barriers and piers that influence the coastal area. And also we have the climate change. Because of that, we have sea level rise, but also extreme weather events. So what do we expect to find out in our pan-European work? We want to understand the processes happening with the interaction and the intermobility between sea and land, between the seawater and groundwater. And we want also to identify such areas in European coast to be informed and take some measures. Also, we plan to identify hotspots along the coastal areas suffering from high rates of subsidence using HGMEs. these subsidence, these hotspot subsidence makes them more vulnerable in the sea level rise. Also, we want to determine the key parameters that influence coastal vulnerability, and we try also to collect all public policies around Europe. That's it from me, but I will introduce Aurelie and Rémi, that they are going to show you the first results of our work. Thank you very much.
Thank you, Eleftheria.
Hi. Hello, everyone. So thank you, Eleftheria, for your this introduction and presentation of the Work Package 5 context. So today we would like to present you a presentation focused on the task 5.1 of the Work Package 5, which concerns coastal vulnerability and climate change. I'm joined today by Rémi, my colleague in the French Geological Survey, who is working also on coastal hazards and climate change. Of course, European partners and geological services are naturally working alongside with us on this project, but today we have chosen to highlight a recent achievement in one of the project's subtasks. So the overall philosophy of the task 5.1 is ask the following question: how to assess coastal vulnerability and coastal adaptation to sea level rise by geological and hydrogeological information. So it is therefore a question of following this general philosophy to demonstrate how coastal vulnerability assessment and coastal adaptation could be supported by geological and hydrogeological information by 3 tasks. The first on investigating a cluster of European sites concerned by concentrated pollutants and nutrients, submarine and coastal groundwater discharge. This task is led by HSGEU, the Sweden Geological Survey. The second task is would like to explain, to work on explaining and projecting spatio-temporal patterns of vertical ground motion in European coastal area and their contribution to relative sea level changes. This is led by BRGM, the French Geological Survey, and the BGS. And then the third task is would work to improve coastal vulnerability assessment, addressing coastal evolution at decadal to centennial timescales and sea level rise impacts. This is led by BRGM. What about our main challenges? It is about help mapping the expertise on coastal vulnerability in Europe, and therefore potentially stimulate new European, national or regional projects involving teams and geological survey. To meet the project expectation while offering an opportunity to increase vulnerability of geological survey in the area of coastal vulnerability assessment, and to build a cluster of European sites and pan-European assessment from related projects. So for the first subtask on the elements that concern concentrated pollutants and nutrients, submarine and coastal groundwater discharge, the first work undertaken to support this task deal with an online questionnaire survey which is dedicated to the question of pollutants and nutrients spreading in the coastal area, mainly from groundwater discharge. So in order to reduce and prevent the risk of pollutants and nutrients, our colleagues from HSGEU and mainly Daniel Madsen would like to collect knowledge of European emblematic sites and to inform data availability in order to highlight the need for harmonization in data. He also would like to highlight geological survey roles in methods or technology, to identify current initiative and collaboration addressing polluant and nutrient dispersal in coastal area, and to define greatest benefit from future collaboration within GSEU projects. He also would like to work and to share decision-making practices and processes like European directive, marine spatial planning, and so on. I'm sure that Daniel will be able to share some elements and present further information in a later date. For the third task of this work package, this is about coastal vulnerability assessment. The first work supports also an online questionnaire survey who was dedicated to coastal vulnerability assessment. So this questionnaire was divided into two parts. The first section to identify the key parameters influencing the vulnerability of coastal territories in Europe, providing an overview of emblematic sites across countries. And the second section to provide elements for an up-to-date inter-comparison between countries concerning the consideration of coastal risk and vulnerability in public policies. The questionnaire was sent to a mailing list of about 20 to 30 partners. Is now closed, and this is not, if not representing the whole coast in Europe, the respondent countries already cover a large part of European coastal area and a great variety of coasts. For example, we ask the project partners about the level of governance involved in coastal risk management in each country, the role of local and regional authorities, the definition of policy and decision-making objectives, the assessment of coastal erosion and flooding in current regulation, and also the role of various parameters according to respondent countries. So you can see here briefly illustrated. Where do we stand today? The online questionnaire is now closed. The exploitation and formalization of results have been well worked in the past 3 months. We are now working on the spatialization of results to produce maps that give a clearer picture of these elements in Europe on a European scale. And now we are working on data cross-referencing with other databases like MONET, dataset, and so on. I won't go into details on these results here, as we will have plenty of opportunity to discuss them later. So for the second subtask of this work package, in last October during the GSEU Day, we share with you this poster to promote the need for work on coastal subsidence in this work package. And this is clear that things have come a long way in the last past year. With modesty, I will let Rémi introduce you this very interesting and very innovative work on coastal subsidence in Europe. This is a study that was carried out by the French Geological Survey with European partners and as part of two European projects, the project Coquelicot and the project GSEU. So just note that this work is an initial focus on the subject, but other GSEU partners are currently carried out or are already carried out work on vertical ground motion assessment too. That's why naturally we still have more cross-analysis to carry out in the near future, as well as future exchanges. So Rémi, you have the floor.
Thank you, Aurelie. Hello everyone. So yes, I'm Rémi, and I would like to thank Eleftheria, Francesco, Krishnan, and for inviting us to give these talks. That's a study on vertical land motion using this new HGMS product, which is a Copernicus product, and which allows to map vertical and horizontal land motion at the scale of Europe. So yeah, it's a collaborative work. I will show the main results. I'll try to stay quick. So sorry if there are too much details. So please, Aurelie, if you can change the slide. Okay, so the problem of this coastal vertical land motion is very well known, for example, in Indonesia and Southeast Asia, because they have very strong subsidence rates. And so here you have an example of flooding in Jakarta. So here in these regions, that the subsidence of the cities is more important than the sea level rise. It's also the case for many big deltas. So this is well known. And actually, there is a paper from Robert Nichols, published in 2021, that shows that if you average the coastline, not by length, but if you weight by population, then you end up with a strong number that people at the coast are experiencing a relative sea level rise of almost 10 millimeters per year, as opposed to this 3.5 to 4 millimeters per year of sea level rise. So this is due to subsidence. So the problem with the subsidence is very difficult to characterize because you can use GPS data, but these GPS data are from stations, so they are basically local points that are really sparse and scarce. Or you can use INSAR, but usually INSAR is a relative measure around like 50 kilometers to something like that, and so you cannot extend it over a very long coast. So, but the thing is, HGMS combines these two methods to provide one new pan-European assessment of vertical land motion. So just another, so please, Aurelie, next slide. Yeah, just, I'm sorry for the quality of the picture, but you know that the IPCC is releasing for each report some projection of the sea level rise. And so on the last report, we have this relative sea level projection at the resolution of 1 degree per 1 degree in latitude longitude. And you see here the problem with vertical land motion. So they are assessed using a specific method that is related to the tide gauge records. So basically they say everything that is not climate related is due to subsidence or to uplift at the coast at the tide gauges. So they use that and then extrapolate all along the coast to have an idea of what are the vertical land motions for each tide gauge. And so here you see the results, for example, for the Po Delta, that we know the North Adriatic is sinking quite a lot. And you see here the projection from the IPCC. So the dashed lines here, so you can't see my screen, sorry, but my map. But so what you see is the dashed lines are the projection of the IPCC. And if you add on top the measurements from GNSS, then you see that they strongly underestimate actually the projection of sea level rise. Okay, because they don't account really for subsidence. And you see on the right, the estimates from the vertical land motion are the blue curve, and the orange curve is the estimation that is observed from the GNSS. And you see that there is a strong difference between the IPCC estimates and the GNSS estimates. So it's not always, so this is a very strong example, of course, but it shows that this is very crucial to project relative sea level rise to better assess the vertical land motion. So next slide, please. So yeah, what we did is we used this new HGMS product to try to assess the subsidence in coastal zones in Europe, because it's only for Europe, this service. Of course, it covers the whole Europe, but we're just going to focus on the coastal zones. And so, yeah, I will enter the detail afterwards. I think I don't need to enter the detail of HGMS now. So maybe next slide, please, Aurelie. So yeah, what we use different data sets. So the first is the HGMS data set itself, and we use the third level product, which is the geometrical product. So basically, it's INSAR-based measurements that are calibrated with a GNSS model. So basically, it's really absolute vertical land movement that we can compare with GNSS results. So it's really within a reference frame that is at the center of the Earth. So what you see, so basically how we can download, so everybody can access HGMS, which is a very good thing, but you can download tiles of 100 kilometers per 100 kilometers. So if you want to cover the full Europe, you need 4 115 coastal tiles. So this takes quite a lot of time to download because there is no API. And then we restrict the analysis only to the coastal floodplain. So what we define as the coastal floodplain is basically a 1 on the 100-year return period event of flooding plus 2 meters of sea level rise. And so we end up with 41,000 coastal floodplains in Europe, within which we're gonna analyze the pixel from the HGMS results. Also, to compare it with independent data sets, we use also GNSS stations that are really devoted to coastal research, that are available on the Sonal portal. So you see the picture on the bottom. So we compare basically the HGMS estimates with the GNSS estimates because they are comparable, because they are supposed to be expressed within the same reference frame. And we also use a GIA model. So glacial is a static adjustment model to remove the contribution from this natural GIA issue. And for the exposure, to better sort of compare cross this subsidence with the assets, we use a Corrine and cover. So please, next slide, Aurelie. So the first things we did, we assessed we validate the measurements from HGMS compared to independent GNSS stations. So here you have an example of the French Atlantic coastline, where you see all the pixels with colors are the measurements from HGMS that are selected to be coastal pixels. And the triangles, the white triangles, are where we have GNSS stations with a very good record. And so basically we use close neighbors. We select the pixel that is the closest from the GNSS, or sometimes we make an average. Also, we test the two things, but we got the same results. And so if you compare the two velocities, you see that you sort of have a good agreement. So it's pretty linear, but there is a bias, a 1 millimeter per year bias. And because we are interested in the vertical land motion that are near 1 millimeter per year, if you have a bias of 1 millimeter per year, then we have a problem, because it means that we cannot really estimate the velocity. So we try to understand why we have this bias between HGMS results and the GNSS results. So next slide, please. And so what we found out basically is that this HGMS product is calibrated to a GNSS model. And this GNSS model is expressed within the European Geodetic Reference Frame ETRF 2000, which is a very quite an old one because it's from 2000, but which is mandatory for Europe. You have to use that one. But there are new ones that are more accurate, and typically the ITRF 2014, within which was expressed the GNSS results we use for calibration. And what you see here, if you do the difference between these two GNSS models, expressed in ITRF 2014 or ETRF 2000, you see that you have a bias and a sort of a drift that changes with the latitude. And we know that ITRF 2014 is better and is more stable than ETRF 2000. So what we did, we re-expressed all these HGMS results within this ITRF 2014. And then we skip this, we don't have this bias problem anymore. So here below you have the equation to correct it. So it's very simple. It's a polynomial fit. And so if you go to the next slide, please, Aurelie, I will show an example of how this corrects the results. So now we can correct the results. What we want to do is for each coastal floodplain to assess the vertical land motion within this coastal floodplain. So I recall that we have 41,000 coastal floodplains in total. So for each coastal floodplain, you see an example of the Arcachon Basin in France here. So you see that these coastal floodplains are with the lines, the gray lines or black line, depending on how many pixels are within these coastal floodplains. And then, very simple, we calculate statistics of the pixels within these coastal floodplains. And so, for example, for the Arcachon Basins over the period 2015 to 2021, here we see sort of like a subsidence that is observed by HGMS on average for these coastal floodplains. So this is the raw data on the B panel, but on the C panel, we correct from the bias, and then we see that we still have subsidence, but we see less strong than if we use the original HGMS data. So this is the example of how we assess coastal vertical erosion in these coastal floodplains. So please, next slide. So once we have that, we can look at all the coastal floodplain in Europe, and here you see the results. So I will go very fast on this slide because it's pretty complex if you want to enter the details. But on the left, this is expressed for each coastal floodplain, and on the right, it's explained depending on the surface of the coastal floodplain. So I would say that the one on the right is more representative of what's happening in Europe. And so what you see is like the gray bar is if you take the raw HGMS velocities, the black bar if you take the HGMS velocities but you correct it from the bias, and the residual one that I call that like the empty ones are if I if I discard the GIA. So the glacial is a static adjustment, which also plays an important role. And what we see from these results is first, if you correct the bias, you have less subsidence than if you don't correct it, which is good. But also that if you remove the GIA, like the neutral, if the coastal floodplain that are not subsiding or not uplifting are a majority. So basically, it shows that if you remove the GIA, then more or less everything, a lot of coastal floodplains are not subsiding anymore or not uplifting. So they are stable, which means that the GIA also plays a very important role in Europe for coastal land movements. But the last point, which is I think the most important one, if you look on the right panel and the black bar, sorry, I didn't finish. So you see that 50% of European land located in coastal floodplains is experiencing currently a 1 millimeter per year subsidence, which is quite substantive. And if now you look at the strong subsidence, which is more than 2 millimeter per year, then you have 10% of the European land in the coastal floodplain that is subsiding at more than 2 millimeter per year, which is very significant actually for coastal exposure. So next slide, please, Aurelie. And so you can do a pan-European picture per country, and what you see is basically blue is uplifting, white is stable, and red is subsiding. And so what you see is like the Northern Europe, as expected, due to the GIA, is uplifting, and the Southern Europe is more subsiding. And especially you see a very strong subsidence hotspot in Italy. You see also in Portugal, in France, there is quite a lot, and of course in Netherlands. So we see that a lot of places are actually subsiding at the coast in Europe. And so you can also go to the next slide, please, Aurelie. You can go. What is very interesting is with the CGMS, you can do European-wide assessment, country assessment, but you can also look at the pixel very in details. And what you see here, for example, is where we have identified hotspots of subsidence. There are many more, but those are quite iconic because, of course, the Netherlands is subsiding. And what you see, it's a very large coastal floodplain, the Netherlands. And the subsidence is very heterogeneous. So you have a very strong one, for example, in Groningen, which is due to gas extraction. But you have also other phenomena that can affect Rotterdam. And overall, throughout the Netherlands, you see that you have subsidence. But it's not the same rates everywhere because there are different processes. North Italy, of course, at the Po Delta is subsiding. This is known, very well known, and very well captured by HGMS. But we can also see at very fine scale, for example, in Thessaloniki, you see that the airport of Thessaloniki is actually subsiding at a very strong rate, but also some assets in the HSGME Delta. And in Italy, we also identified a region at the coast, which is Chiavonia, which is in the south of Italy, where also a strong subsidence is found. And actually, you can repeat that for almost all the coast in Europe, and you will see somewhere region where you have strong subsidence that you didn't expect. And next slide, please. And so as a final word, what we could also do is like to take this pixel of the GMS and compare it with the land cover. And we focused on the strong assets, which is the cities, urban fabric, harbor, and airports. And what you see from this table is that urban zones and population in flood-prone area are experiencing a mean 1 millimeter per year subsidence if you exclude the Finno-Scandia, so basically the northern countries. And what is, I think, a very important message also is like, if we focus on airport and harbor, we also see that the subsidence is larger, is even larger. So 1.5 millimeter per year of subsidence for harbor region, and more than 1 millimeter per year for airports, which is like these coastal infrastructures are sinking faster than the rest, which of course pose problems for how they will adapt. They have to adapt faster to sea level rise than just climate induced, but also account for subsidence. So I think I go to my conclusions. So this study is published recently in Future. What we've shown is, so basically it's the first time that we do a pan-European coastal vertical emission assessment using HGMS. HGMS is updated every year. So, and every time you have on HGMS portal 5 years of data. So you can collect all this and then have a very long time period, timeline of data and make better assessment in the future. So it's a very useful product. What we found is like the urban zones and population in flood prone area are experiencing a mean of 1 millimeter per year subsidence if we exclude the Northern Europe, and the harbors even more, which of course poses problem for adaptation. And I'd say, and I think is a very important point, but we also identified that the geodetic reference frame used to calibrate HGMS can affect the results. So this is very important to account for. If you want to have the best possible estimate, you have to account for these corrections. So yeah, what we plan in the future is to, of course, update permanently this study using this new version of HGMS to see where the signal is robust, where the signal is changing, because there are small changes also with the different versions. And of course, the idea is at the end how to use those data that are observed over a quite short period to project hazard in the future and exposure. So this is a challenge, and we have to understand the causes of subsidence to better frame that part. And of course, we plan to release the data set. So it's already on the repository, but we plan to release it on the platform. So this is still remains to be discussed. Okay, I thank you for your attention.
Thank you very much to all the three presenters. Now I'd like to ask you also Eleftheria to join back online. So I have a couple of questions for you, while the audience is welcome to join at any time. So when we're talking about the European project, we only talk about having an impact. So the first question that I'd like to ask to the three of you, and up to you who wants to start to jump in, why the work that you are carrying on is important for European citizens?
Well, I think yeah, I can start, I think.
Of course.
No, I mean, I sort of already answered that question in the introduction, but I think sea level rise is clearly an issue. And we know that this is going to be an issue for the next centuries, actually. And now we experience a sea level rise of 3.5 millimeter per year. We know that it's accelerating. And we know that we're going to end up with 2 millimeters of sea level rise. So this is definitely to be an issue for coastal population as coastal hazards increased. But one has been long missed in this assessment is the vertical land motion, which locally can really enhance the sea level rise and go to the fact that if you have a subsidence, you have to adapt quicker to sea level rise than if you don't have. And this is what we found in the study. It's like very localized for port, for airport, for some cities. And so having this new tool really will allow to better adapt and to better assess your local conditions and to answer as a function of this local assessment. And this is available for everyone, which is a very good thing.
Thank you, Rémi. Aurelie, Eleftheria, you like to implement extra or wanna to move on?
It's perfect.
Yes.
Yeah.
Yes, I would like to add that for every citizen, it's good to know the exact size of a problem. So what we do is to assess where we have these problems, so everybody can see. And of course, the policymakers, the government, the local authorities should take some measures. That's my answer.
Thank you. When I actually, during your presentation, Eleftheria, pop up an extra question. So why it is important from a technical point of view to understand the interaction between sea and freshwater?
Yes, well, we have some pollutants that are in the groundwater, and in certain conditions they can contaminate the sea. So we have to see where these hotspots are and to try out to understand how we can influence, if we can, to stop this happening. Also, if we have overpumping near the sea, then the sea water comes in our wells, and this is catastrophic for the greens that we are going to water.
Thank you, Eleftheria. I think quite of a bit of the work that is carried out is also a lot of colleagues, some working, for example, on the EMONet and on Copernicus services. So can you tell us a little bit more about how the interaction working between the GSEU, EMONet, and Copernicus?
I would suggest that Rémi would tell that.
Well, I think Copernicus is definitely something that that is growing, and that is well, for example, EGMS is really an initiative from Copernicus, and then you can, I mean, you can really see that you need connections between what is available on Copernicus and what is available on EMONet. And I don't know whether the status of how to bridge all this knowledge, but I think we go in the right direction. And in addition to EMONet and Copernicus, I'd like to also advertise that we are soon releasing a platform, which is a COCLICO platform. COCLICO stands for Coastal Core Climate Service, which will be a platform that will allow to visualize and assess your risk at the coast, risk of flooding and risk of erosion, which also at the end will be part of, should become, we hope, part of Copernicus too. Yeah.
Yeah. Thank you. I do have a last question for you before closing the webinar. So if you will have to give a suggestion to European or national policymaker about how to use the data and the product that we developed in the GSEU, what would you tell them? It's an easy question.
Okay, so what is the answer? Usually we go out and show to the people and to the policymakers geological data, geological maps. But this is not the answer for everybody, because nobody, I mean, very few people can understand what we are saying, strictly speaking about geology only. So what we try to do is translate this information to some elements and some indexes that can be understood by the policymakers. So this is what we want to do, to give to the policymakers to understand what is the problem and how they can solve it. So this is our contribution.
Yeah. So we want to come up with like sort of bringing solutions, and also to be a bit of an interface between really technical data and conversation and more let's say political level.
Yeah.
Yeah.
Maybe I think there is trying to work with practitioner, with not politics, but with cost and manager. Sometimes it's difficult to convey a message or to make people understand that the work we do is with a lot of uncertainty. Some are quantifiable, some are not quantifiable. So I think there is a big effort to do for scientists, but also for communities to co-work, to co-develop things, that we develop products that are usable for the people that need this product. So, and I think it's a big challenge actually. So how to communicate the results and to make it usable. I think it's maybe the most important.
Yeah.
Thank you, Rémi. Then I think that I'd like to really thank all the 40 people that have been staying with us for this hour. And a biggest thank as well, of course, for Eleftheria, Aurelie, and Rémi. Thank you very much for your work and for being with us today. As Eleftheria mentioned at the beginning of her talk, we have another webinar in 5 days from now, September 29, to talk about offshore wind farm siting. So if you also like to join them, you're very welcome. And in a couple of days, you will find the recording of this webinar on our communication channel. Thanks again, and I will see you all to the next event. Bye, everybody.